This video will identify how the Professional Line Design Program will create an improved engineering culture designed to comply with required state and federal regulations and incorporate engineering software to achieve best practices in the distribution line design industry, and develop, operate and maintain a superior joint use program. Engineering is legally defined in all jurisdictions, and the Code of Ethics requires engineers to hold paramount the safety, health, and welfare of the public. The engineering profession incorporates best practices based on lessons learned from accidents and disasters, opportunities from technological advancements, and research aimed to minimize risks. By incorporating best practices, engineers ensure their designs comply with NESC requirements. There are several concerns with current Montana engineering procedures that include non-compliance with Montana Statute 37-67-314 where NESC calculations are not performed, and the professional engineer is not affixing their seal and signature to final designs. Current procedures also impacts compliance with Federal Regulation 1724.4. Based on modeling over 50,000 poles, cooperatives may have a significant number of undocumented NESC violations. In addition, most cooperatives have weak joint use programs, and several cooperatives claim telecom companies attached to power poles without permission or an engineering-approved design. Current engineering procedures for most cooperatives include the design technician making engineering decisions based on design guidelines and personal experience. Profile drawings are rarely performed, and field measurements are rarely documented. The staking sheet is then either released for construction, or a non-licensed supervisor reviews the staking sheet, before releasing for construction. Federal Regulation 1724.32 then requires a professional engineer, or a non-licensed subordinate if approved by the cooperative, to perform a work order inspection by making a field trip to approximately 20% of new installations. During the field visit, the professional engineer will perform a visual observation on newly installed power lines to review NESC compliance, inventory accuracy, and compliance with construction specifications. As a result of using this procedure, 80% of new installation projects are not reviewed by a professional engineer, and NESC calculations are rarely performed and documented. Ethical engineering procedures is common practice in the engineering profession and requires compliance with Montana state registration and licensing requirements. The design technician creates an engineering design document which includes completing all required NESC calculations and provides necessary documentation, then forwards the initial design package to the professional engineer for review and approval before construction. Montana state registration statute requires the professional engineer to affix their seal and signature to the final design, which serves as a legal and ethical certification that the work meets the required standards and is suitable for its intended purpose. It also signifies that a qualified and licensed professional has personally overseen the design and takes responsibility for its integrity and safety. The purpose of the compliance plan is to create a professional engineering culture by complying with state and federal engineering regulations, achieve best practice in the distribution line design industry, and operate a superior joint use program. The first step in this process is to complete the Engineering Compliance Assessment form. This assessment should provide an overview of existing engineering procedures and areas to improve the engineering procedure. The second step is to meet with each cooperative to develop a compliance plan to comply with state and federal regulations and best practices in the industry. The compliance plan will include a budget and schedule to achieve engineering excellence. This will then be followed with a 3-day training program to review the professional line design program and perform over 100 primary, secondary, and joint use designs, and then implement the compliance plan, which will include recurring progress reports. Completion of the compliance plan will vary based on cooperative involvement and if additional field data needs to be collected. While engineering decisions in distribution line design have remained relatively unchanged during the last several decades, transmission line design has made continuous improvements since the mid-1990s. Transmission design always included profile drawings and performed several NESC calculations based of our U.S. Bulletin 1724E-200 requirements. Then during the mid-1990s, transmission companies began to incorporate engineering software that performed all required NESC calculations. Then in the late 2000s, most transmission companies performed system modeling to identify, document, and correct all NESC violations. By incorporating these best practices, the Montana cooperatives will be in compliance with Montana Statute 37-60, 7-314. In addition, Montana cooperatives will identify, document, and budget to correct existing NESC violation and incorporate a superior joint use program. An engineering design document is developed during the initial design phase and produces a profile drawing and engineering report on required NESC calculations. The designer can easily identify and correct any design deficiencies before creating the staking sheet. The engineering design document is electronically submitted to the professional engineer for final review and approval. This will provide off-site professional engineers with the ability to review and approve designs before construction, which is a common practice in the engineering profession. The professional engineer can affix their seal and signature to the final design, which is required by Montana Statute 37-67-314. All overhead line sections will be supported with profile drawings where the phase and neutral conductors are displayed under final sag, loaded conditions. Each span identifies a generic along span clearance, plus one vertical ground clearance based on ground type. Ground types are user-defined in the standards and design criteria. Ground types typically include items like driveway, field approach, county road, highway and railroad, and the user documents the required vertical ground clearance. The professional line design software maintains NESC calculation results for each pole location. Each line section documents true ruling span and true loaded design tension, and each pole location documents all required strength and clearance calculation results for primary, secondary, and joint use installations.